Point-slope form. A useful form of the equation of a line is the point-slope form. Its equation is y minus y1 equals m times the quantity of x minus x1. It's based on the use of the slope and any point that is on the line. This equation is the most effective when you are given the slope and a point on the line because you can use it to write the equation in multiple forms. So let's get started to see exactly what that means. Point-slope form starts using the definition of slope, in which 2 points on a line are given by the ordered pairs of x1, y1 and x2, y2. As a first step, let's just name the coordinates for the second point, xy, instead of x2 and y2, so it'll be more general. So that will be true for any point on the line, not just one point, and that will allow us to write an equation for all points on the line. So then our slope formula, instead of y2 minus y1 over x2 minus x1, becomes just y minus y1 and x minus x1. Now let's solve that equation for y using what we've learned about solving equations. And hint, remember to treat the denominator of x minus x1 like it's in parentheses. What would we have to do to isolate that variable y? Well, the first thing we would have to do, if it's dividing by that quantity, that denominator of x1 minus, or x minus x1, we would have to multiply both sides of the equation by x minus x1. So that would give us, right here in this second step, we would have m times the quantity of x minus x1 equals y minus y1. And then our last step is to switch the expressions to the opposite side of the equal sign, so that we would have y minus y1 equals m times the quantity of x minus x1. So even though we haven't solved for y completely by itself, we have reached this point-slope form in our equation, so this is where we're going to stop. And now we can conclude that we have point-slope form of our line, which is y minus y1 equals m times the quantity of x minus x1, and it gives us two key pieces of information right in the form of the equation. That coefficient right in front of the parentheses of our x term, m, is the slope, and we have the numbers x1 and y1. That is any of the infinite points that satisfy the equation, any of the infinite points that lie on the line. So that's where we get the name from. Point-slope form is because you literally see the slope of the line and one of the infinite points that are on that line as well. Now, if you are provided a graph of a line, you can calculate m and locate a point directly from the graph. That allows you to write the equation of the line directly because we now have this point-slope form, and then we can use that to find any other needed points on the line. For instance, if I know that the equation of a line is y minus 1 equals 3 times the quantity of x minus 2, then that equation is written in point-slope form, and we can see that one point on the line is going to be 2, 1, from the x1 and y1 values, and that the slope of the line is 3 from the value of m. So we can plot the point 2, 1 on our graph, that's this blue point here, and then using this we can find a second point on the line using the slope of 3 and then draw the line. From that given point we can go up 3, right 1, up 3, right 1 to get more points on that line. So that's what we're doing here as well. Now you can go up 3 units on the y-axis or right 1 unit on the x-axis, but you could do multiples of that as well. Instead of 3 over 1, you can go up 9 over 3, you can go up 6 over 2, any multiple of 3 over 1. But then you can connect those points and you can draw the line. So this method is easiest to use if you have to draw a line given a point and a slope, because then you can have your equation in point-slope form and you can easily graph from there using the point and the slope. So let's look at another example. It tells us to graph the equation of y minus 4 equals 2 times the quantity of x minus 6. So the first thing to recognize is this equation is written in point-slope form. It's y minus y1 equals m times x minus x1. So we can see from this equation a point on the line and the slope of the line. We can see that the line passes through the point of 6, 4 from x1, y1, and that there's a slope of 2 from that coefficient of the parentheses of x. So we can start out by graphing 6, 4, that's this first point here. And then we can use the slope of up to right 1 to get our next point to draw our line through. Here's another example. So here we have the equation y plus 2 equals 1/3 times the quantity of x plus 4. Now, this equation, it might look different from point slope, right? Our point slope equation, you're used to seeing subtraction. Y minus y1 equals m times x minus x1. It's still easy to see that the slope is 1/3, but you have to be careful with your values of x1 and y1 because of the subtraction in the formula. Because of the subtraction in the formula, you want to think that y plus 2 is really y minus a negative 2, and the value of y1 is going to be negative 2, the opposite of the 2 that you see. Same thing with x1. If you have x plus 4, that's really x minus negative 4, so x1 really is negative 4. It's the opposite of that positive 4 you see. So from the equation, we know the line passes through the point of negative 4 and negative 2. From that positive 4 and positive 2, we're using the opposite of those values to get our first point. So that's what we graphed first, negative 4, negative 2. And then using the slope of 1/3, we went up 1 and right 3 to get our other point to connect with a line. So with point slope, you can automatically see your slope and a point on the line, and just be careful if you see in point slope form the y1 and x1 values, you have to make sure you're remembering the subtraction in the formula tells you it's the opposite of the number you're seeing if you see plus signs instead of minus signs.